Okay, hello and welcome to video 2 on statistical testing in biology. And today we are looking at the student t-test. Now, the student t-test is used to determine the significance between two sets of data that is collected. And there are two different types of student t-test. There is what we refer to as the paired student t-test and the unpaired student t-test. So what we're looking at is the mean of the data that we collect. If we have two sets of data, are their means significantly different from each other? So what that means is that there might be a difference in the mean, but is that mean difference significant? Is it statistically significant that we can say, yes, something has caused excuse me, that difference in the means? So I'm going to start by talking about the paired student t-test. So in the paired student t-test, we have two sets of data that have come from a group of individuals, but the same individual has contributed data to the first set and the second set. So for example, we might compare the pulse rates before or after exercise. We might compare a set of patients' blood pressure before they've taken a drug and after they've taken a drug. So in the paired student t-test, it's the same individuals that have contributed to both sets of data. Now, it's a fairly simple equation. We work out our value of t, and I'll come back to what that means a bit later. But our value of t, we work out by doing the average of the means differences, multiplied by the square root of the number of samples divided by the standard deviation of the differences. And I will go through all of that in a second. For our unpaired student t-test, we have two sets of data, but they are not from the same individuals. So it might be that we're looking at heights of plants, says here, grown in the sun or in the shade. We might be looking at length of leaves on plants grown on loam soil or clay soil. Okay, slightly more complicated equation. We've got the mean of data values in group A minus the mean of data values in group B, and we divide that by the standard deviation of group A squared, that's divided by the number of individuals in group A. We add that to the standard deviation squared of group B, divided by the number in group B. We square root it, and then we divide that into our x bar A minus x bar B. Now, don't panic. In an exam, it is highly unlikely that you are ever going to be asked to work out every single piece of this equation. You will probably be given all of the numbers and asked just to do the calculation and then discuss what that means. Or you might have done in a previous part of the question, worked out perhaps a standard deviation, and then you're going to slot it into this equation. But you'll not be asked to calculate all of this data from scratch. So let's start by having a look at the paired student t-test. So before we start this, we have to come up with what we call a null hypothesis. Now, for those of you that do psychology, you may have come across the null hypothesis before. And essentially, what a null hypothesis is we assume that there is no significant difference between our data sets. Any differences are just due to chance. And what we are going to do is we are statistically going to prove this one way or the other. Are the differences statistically different, significantly different, or are they not? Okay, and that again will become apparent a bit later on. So here is our first data set. We have got some pHs of some ponds, 9 ponds, taken at dawn and at dusk. Okay, so here are the pHs taken at dawn. Here are the pHs taken at dusk. Are they significantly different? Our null hypothesis says no. There is no significant difference in the pH of water in a pond at dawn or at dusk. What we are going to do is use the paired t-test to decide whether that is true or not. So first thing we need to do is we need to calculate all of the differences. So we need to take away the the dawn pH from the dusk pH. And that is what I've done here. So here are all my differences. Okay. Remember, for our equation, we want d bar, the mean of the differences. So we just work out the mean of these differences, and it comes out to be 0.190. We already have our value of n, the number of samples in the group. That's 9. Okay, so it's not individual samples, it's individuals that have contributed their samples. So we have 9. Now we need to work out the standard deviation of the differences. So remember that from the other lesson, that's the spread of this data. So these are our data sets. This is our mean of our data sets. So if we have a look at this table here, all right, that's our value of x, 0.19. That's our value of x bar. Sorry, these are values of x. Sorry, my bad. These are values of x bar, x minus x bar for each set of data. X minus x bar squared, okay, is in here. We add that together. So that's this top value here. We divide that by the number of data sets minus 1. So we have 9 data sets, so it's 8. And then we square root it, and that gives us a value of 0.129. This is our standard deviation of our differences. So if we go back to our student paired t-test equation, our value of t is equal to the mean of the differences multiplied by the square root of n divided by the standard deviation of the means. We've got all 3 of those numbers now. We worked out the mean of our differences, 0.19. N is 9. Standard deviation of our differences is 0.129. We plug all that into our equation and we end up with a value of t of 4.42. Now, when doing your calculations, I highly recommend that you lay them out like this. Don't just plug all the numbers into your calculator and press equals. It's going to go wrong. Check each calculation twice as well. All right, have you done it correctly? Now, I didn't actually plug the square root of 9 into my calculator because I know it's 3, but I have written it out in my next step here. So we have a value of t. Now, what does that value of t actually mean? So what we have to do with this value of t is we have to look it up in a table of values. Now, lots of statistical tests have tables of values that show us whether our data is significant or not. And across the top, you have the probability or the percentage that we can accept or reject our null hypothesis. And in all statistical tests, the critical value is at the 5 degree or 5% level of confidence. So we are 95% confident that we can reject our null hypothesis. Okay, so that is significant. We are 5% confident that we could accept it, but this is what in the statistical world this is deemed to be the critical column of data. Again, in an exam, it is unlikely that you'll be given a whole table of data and asked to look up the critical value. You'll probably either just be given the critical value, or you may be given a row in the table, or maybe a couple of rows in the table, because it wants you to perhaps work out your degrees of freedom. I'll come to in a second. So we always look up this row here, the 5% or 5% degree of confidence. We then have to look down here to find our degrees of freedom. Now, for this particular test, for a pair student t-test, our degree of freedom is a number that we have in our group minus 1. So we have 9 sets of data, which means that we have 8 degrees of freedom. So our critical value is 2.306. And the rule of thumb is, if the value is above the critical value, we reject our null hypothesis. If it's below the critical value, we accept our null hypothesis. Our value was 4.42, so we can reject the null hypothesis. There is significant difference in the pH in ponds in the morning, at dawn, or at dusk. Okay, we can reject our null hypothesis. There is a significant difference. Okay, so that is the paired student t-test. Moving on, we then have the unpaired student t-test. And this is where we have different groups of individuals that have contributed the data. So we might be looking at the means of, as I said, a group of plants that have grown on loam soil or clay soil. Or we might be looking at, what was the example we had, the height of plant grown in the sun or the shade. Now for this particular example, we're looking at the mass of elephants. Okay, I don't quite know what happened to this one here. This was missing. There was some data. Oh, there it is. There it is. 1.6. Let's pop it back in there. Right. Okay. So we're looking at the mass of elephants. So we've got the mass of bull elephants, the mass of cow elephants in tons. On average, this particular sample of 16 bull elephants weighed 4.7 tons. Cows, 4.4 tons. Is that significant? Our null hypothesis will be there is no significant difference between the mean size of bull elephants and cow elephants. Okay, these differences are just purely down to chance. So, a slightly more complicated equation. I'm not going to show you how I worked out the standard deviations. We've done that twice now. We're just going to plug the numbers into the equation. So we've got the mean of group A, 4.7, minus the mean of group B, 4.4, divided by the square root of the standard deviation squared of group A. So that's 0.22509 squared. Got to put that in. I'm going to put that in now. My bad. Sorry, people, to ignore me. Ooh, let's try this. Squared. Ooh, there we go. Plus the standard deviation of group B squared divided by the number in group B. Okay. I'll square root that. Anyway, to cut a very long story short, our value of t comes out to be 4.431. Okay. Again, we then go back to our table. Now this time, because we have two groups of individuals which are not related, they've not contributed both sets of data, we add up our degrees of freedom. So the number in group A minus 1 plus the number in group B minus 1. And that comes to 30. That was 16 in group A, 16 in group B. We go back to our critical value. This time our critical value is 2.042. Okay, it's above the critical value. We are going to reject our null hypothesis. There is a significant difference between the average mass of that group of male elephants and that group of female elephants. Okay, so what I'd like you to do now is to have a go at the question that's attached to this homework. It is fairly straightforward. You do not have to do any of the standard deviations. They've given you the means and they've given you the standard deviations. So just make sure you open up the question that's attached. This is just a quick snip of it. Make sure that you open up the question, have a go at the question, and please see how you get on. Okay, thank you very much.